Stangibelisco here. Just a little bit of a radar update for winter storm whatever. Let's see, April 29th, 2014, 11:43 a.m. Mountain Daylight Time. I am located between Sturgis and Newcastle, so I'd be right about here in Lead, South Dakota. It looks like we're going to get another round of precipitation here. We've probably had close to 30 inches of snow in the past 48 hours. Fortunately, it has fallen over a period of time and never became extremely intense. Although last night I woke up this morning thinking, we got a couple inches, because it had been blowing, and it blew off the deck railing, which is what I usually use to gauge the amount of snow. And when I got down to the driveway, it was a foot. But I got out, I swam my kilometer, came back, shoveled my way back in. I mean, I'm ready for lunch. This is the composite loop radar. There's Sturgis. It's centered at Ellsworth Air Force Base, just east of Rapid City, right there. This is South Dakota. Gillette, Wyoming is over here. Buffalo, South Dakota is up there. Faith, South Dakota up there. Now, let's look at this Doppler radar, the velocity. Let's look at the velocity loop. Now again, this is centered on Ellsworth Air Force Base. That's where the radar is. It's just east of Rapid City. I'm pointing at the center, and you can see where these red and green regions converge or kind of touch each other there. That is where the radar is. Now, in the Doppler radar, green colors indicate precipitation droplets or snowflakes or particles moving towards the radar. Red indicates the particles moving away from the radar. So the general actual particle movement you can pretty much consider to be like this, going from north-northwest to south-southeast. Now let's go back again and look at the reflectivity loop. Now I told you that the actual motion of the particles or drops or snowflakes is from the north-northwest to the south-southeast. So it would be a north-northwesterly wind blowing those particles at whatever level this Doppler loop is. I don't know exactly what altitude that is, by the way. I'm not really sure about that. I don't know. It would be interesting to find out. Anyway, the motion of the storm precipitation regions themselves is kind of hard to ascertain here. They kind of form and then disappear, and form and then disappear, but the general gist of the motion I seem to get is more like from the north-northeast to the south-southwest. And I presume that's at the surface, the base loop. Let's look at the base loop. That would be closer to the surface. Yeah, you can kind of sense the motion going like that in this system. However, with the velocity, let's look at the base velocity. Okay, now you can see here too the general motion of the precipitation region seems to be like that. But the Doppler indicates, if you go at a right angle to this tangent region there, it seems to kind of indicate that there's wind shear here, that there's some kind of change in the direction of the wind between these two radar readings. Anyway, that's what the Doppler radar means. So when you see that, green means that the water droplets or snowflakes or ice crystals or whatever they are, dust for that matter, is moving towards the radar. And the brighter the green, the more rapid the motion, I would suppose. The same with the red down here, except that indicates motion away from the radar. Towards, away. So now I've got it straight. I had it wrong. I had it exactly reversed. And that's why I deleted those other videos that I made of this. But this is the storm as it is at about noon now on the 29th of April. Winter here in the Black Hills is 7 months old. And it doesn't really seem like it's loosening its grip yet. I don't mind it though. I didn't move here to get a suntan. I did that in my younger years. The bill's coming due now, I'll tell you that. Stan Gibilisco signing off. Till next time. So long.